All right, so for October 6th, our notes are finding slope and graphing lines. So the first thing we need to understand here is that slope. Okay, all this is going to be review, again, from algebra. We're in a time machine going back to Algebra 1. The slope is going to measure the steepness of a line. Okay, so that's going to be your steepness of that line. Your slope formula, you can either do the in the numerator the y2 minus y1 over x2 minus x1, or if you have it on a graph, you can just you find 2 points, 2 clean points, and you can do your rise over your run. So finding the slope here, we're looking here at this first example. We're going up a hill, so we need to remember that this is going to be a positive slope. Right? So we have a positive slope. The next one, we're going to see that we are going down the hill, so we're going to have a negative slope. When we're going straight across like this is we're going to wind up having a zero slope. And I'm doing these little symbols for a reason. Okay? So this is going to be your zero slope. And the last one we have, when we are near vertical, we're going to have an undefined slope. So the reason I was drawing the pluses and the positive and the negatives and these circles and this little U-looking thing right here for undefined is because we need to be reintroduced or introduced to the slope man. Okay, I always call him Mr. Slope Guy. So what he's going to look like, we're going to draw his head right here, and we're going to draw in his face. We have here, for his left eye, we draw in a positive slope with that plus sign, seeing that it's going up, we have positive. His other eye is going to be the negative sign, and there's going to be your negative, what your negative slope looks like. And I'll go to his nose now. His nose, this horizontal, this vertical line, that's going to be the bridge of his nose, and then here's his nostril, the tip of his nose, for U, for undefined. And then we have his mouth that just goes horizontally straight across, and he's got his little dimples here that represent that zero. Another way that you can remember this is what we see here, the VUX, and we also have HOI. VUX, V, U, X. V stands for vertical. U stands for, when you have a vertical line, it is undefined. There's an undefined slope. And you will notice this is when X is going to equal a number. So when your X coordinate is the same, if you have two coordinates and your X is the same, that's where we have X is going to be that same number. And we have VUX. We have a vertical undefined slope. Then your HOI, we have H, O, Y. Your H is going to be horizontal. This helps out with your, not the positive and negative, but this right here is actually going to represent a zero. Okay? So this helps out with your undefined and your zero slopes. And this is going to be where you notice that Y is going to equal a number. Either you have an equation that says Y equals 7, or you notice that you have two coordinates in your Y, or you have two sets of coordinates and your Y coordinates are exactly the same. Okay? We'll take a look at that here in a moment. So here is your formula for your slope. It's also, you'll also see it is known as your change in Y. Delta Y means change in Y, triangle Y, over your change in X. And that's what we're doing here is we're finding how did it change from one coordinate or one point to the next. Also, when you're on the graph, you can use your rise over run. So the first example here, we're going to go ahead and label our X's and our Y's. We have X1, Y1, just like we did with midpoint and distance formula. We have X2 and Y2. So to find slope, which is going to be M, on top in the numerator, we're going to have, as it says in our formula, Y2 minus Y1. So we're going to Y2, 8, minus the Y1, which is 2. In the denominator, we're going to have X2, 4, minus X1, which is a negative 6. When we simplify this out, 8 minus 2 is going to give us 6. Here we're going to have 4 minus a negative 6, which remember this turns into a 4 plus 6. We're going to get 10. We need to make sure that our fraction is simplified. Here we can divide both 6 and 10 by 2. And we do that, it simplifies down to 3/5. And that would be our slope between these two coordinates, or sets of coordinates rather. Next, here we go, x1, y1, x2, y2. We'll go ahead and go find our slope. We're going to put on in the numerator x2, your -3, minus x1, so minus a -3. And down the bottom here, we're going to have -1 minus a 2. So we have -3 minus a -3. Remember that minus and negative becomes a plus, so we have a -3 plus 3. It's going to end up canceling out. We're going to get a 0. And this will be all over -1 minus 2 is a -3. So when you have a 0 in the numerator, okay, well, I know one's going to be undefined, one's going to be, the 0 slope. Well, go take a look. We talked about earlier right here with Vux and Hoy, which coordinate should stay the same. We notice that our y coordinates stay in the same, okay? So we have a -3, so that means y is always going to be -3. So that's your y equals -3. We have a 0 slope. Also, if you put this in your calculator, it will tell you the answer is 0. So here we're going to have a 0 slope. Last problem, let's go ahead and label x1, y1, x2, y2. And let's go figure out what our slope is going to be. Top, x2, 6, minus x1, -3. Denominator, x2, 2, minus x1, 2. 6 minus -3, it's just saying 6 plus 3, we're going to get 9, over 2 minus 2. Oh, look, now we have a 0 in the bottom. So I just put a 0 there. All right, so we have a 0 in the denominator now. So again, if you take a look with our Vux and our Hoy, we see here their coordinates, our x coordinate is the exact same. So x is always going to be, every single x coordinate is going to be 2, meaning x equals 2. So we have undefined. Or if you put in the calculators at school, it will actually tell you undef, which means undefined. So here we have undefined. So now we're going to take a look at graphing our equations. We worked with on the 5th how to convert our equations into different forms. So we have our slope-intercept form, we have our point-slope form, and we have our standard form that we talked about. The first thing we need to do is plot a point from the equation. Then we're going to use our slope, our rise over run, to find the next point. I usually put a couple more on there, and then we're going to connect them. Okay, so I suggest having a ruler with this guy here. Let's take a look at the first one. We like to have it in our slope-intercept form, y equals mx plus b. This makes it a lot easier for us to graph. The first thing is we need to plot a point from the equation. That point is going to be right here, which is going to be your y-intercept. Okay, so this is that b in y equals mx plus b. So that'll be your y-intercept, which is going to be a positive 5. So we're going to go to our graph and we're going to find 1, 2, 3, 4, 5. Right at positive 5 on the y-intercept, where it crosses the y-axis, we'll put that point. Then we're going to take our slope, which remember our slope is what is in front of that x, that coefficient in front of x. So m, our slope, we're going to see is a -1/2. So we need to remember this is our rise over run. Yes, sometimes it is a fall over run. We see that negative. We need to go back to Mr. Slope Guy and see that, or our graph up here, we need to see the negative is going to go down into the right. So we're going to go down 1 to the right 2. And like I said, I like to put a couple of them on there. Down 1, right 2. Down 1, right 2. That way I can get that line a little bit more straight. And I'll line all of these up, and I'll connect them all. And if it's not perfect, no big deal, as long as we've got a few points on there. Okay, and there's our line. So our next problem, the example number 3 here. we're given point slope again, so again, makes this pretty easy here. We're going to find our y-intercept B is going to be a -2 this time, so we're going to plot that point at -2 on the y-axis. And then our slope is going to be a +3, which we need to make into a fraction so that we can have a rise over run. So this, turning a whole number to a fraction, we just simply put a 1 underneath it. So we're going to rise 3 and run to the, always run to the right, run to the right, run to the right, okay? So we're going to rise 3, because it's positive, and then go to the right 1. So 1, 2, 3, right 1. Rise 3, run to the right 1, okay? And then we could go ahead and connect these points the best we can. And we've got our line. Make sure you're putting those arrowheads on the end, okay, to show that it is a line, not a segment. All right, we're going to graph 2 more, but this time we're going to have to do a little bit of work first, okay? We're going to have to step back to our converting. So first we have standard form, which we need to convert, and what I've been telling my students is there's 2 steps. Step 1 is move x to the right side of that equal sign. So the first thing I need to do here is get rid of that 3x. If I have 3 x's, I need to take it away or subtract. So we're going to subtract that 3x from both sides, so it's gone. We need to be very, very cautious here and see that we have a -4y. Okay, so we bring down that -4y is equal to, I want to make sure that this x goes first, so that -3x, I always say that minus and negatives are like double agents, because now instead of -3x, it's going to go in front and become a -3x. We have a +24, so we bring that down as +24. And then our last step in solving for to go from standard to slope intercept is we need to divide all terms by the number in front of y. So that would be a -4 in this situation. So the -4 in front of the y is gone. Y is by itself. We're getting where we can graph it. We have a -3 over a -4. Well, we know we're going to have that x down here. We're going to don't forget your x, bring that x down. That -3 over -4, the 3 and 4 cannot be simplified, but we need to check out that we have negative on both of them. We know that a negative and a negative is going to create a positive. So we're going to have a +3/4. And then when we take this, we have a +24, but we're dividing it by a negative. Positive divided by a negative gives you a negative. So we will subtract 24 divided by 4 is 6. So again, here we have our y-intercept. B is going to be at -6. So we're going to go down 1, 2, 3, 4, 5, 6. Plot -6 on the y-axis. That's why it's called the y-intercept. And then we're going to see here our slope is going to be +3/4. So we'll go up 3 to the right 4. So up 3 to the right 4. Plot a point. Up 3 to the right 4. And I'm going to wind up off the graph. So we can just go ahead and take these and connect them, making sure we have the arrowheads at the end, saying that we have lines, not segments. Next problem, I'm seeing it's in standard form again, so we need to make sure that we convert this. We're going to take those same steps. First, we're going to move x to the right side. So we need to subtract that 7x from both sides. We're left with -5y. Be super careful with that. -5y is equal to, want to put that -7x first. And we have a +45, so it'll be +45. The last step is divide all terms by what's in that number in front of y. So we're going to divide all of these by a -5. So 5's in front of -5's in front of the y cancel. We have y equals, we know we're going to have an x, we're going to bring that x down. We have a -7 over a -5. So we know those negatives are going to cancel to give us a positive. 7 over 5 is already simplified. So we're going to have a +7/5x. Then we have a positive divided by a negative. So we're going to have a negative. 45 divided by 5 is going to give you 9. So here we have -9 as our y-intercept. So -9 on the the y-axis. It's actually way down here, so it'll be the second to last point right here. And then we see that our slope is a positive. So it's going to be rise 7 and run to the right 5. So we'll go up 7, 1, 2, 3, 4, 5, 6, 7. And we're going to always run to the right 5. 1, 2, 3, 4, 5. And if you want to add another point in there, you can. You can go at another rise of a run. Or if you'd like to just kind of save time, we can just connect those two the best we can. And we could form our line. Okay, and that is your reminder of how to find slope and how to graph your equations.